Okay, welcome back. Mic check looks good. So let's continue on with oops. So I had uh yep, so my last video was the mentoring that I'm doing. So the video before that was the book. So let's continue on with the book. We're moving on to association rules. Association rules are frequently the basis of many recommendation systems algorithms from Amazon, Netflix, and other tech companies that Amazon, Netflix, and other tech companies will use to push a recommendation to you based on your purchases. You might want to buy this. Now imagine a world where this sentence is different. Instead of based on your purchases, you might want to buy this. What this was based on what based on your weaknesses, based on what's going wrong in your life. Not only might you want to buy this, you can have it for free, or even we will pay you to have this because it will reduce cost to society. So let's say you're having back pain. Based on your medical history of back pain, this set of physical therapy exercises, which, a lot of people, if they have back pain, they will go see a physical therapist and do those anyway. But, imagine a world where you're paid to do that, and you're constantly reminded and recommended, hey, you've had this problem. All the data, randomized controlled trials, just like, instead of being shown Coca-Cola stuff you want to buy, you're shown hyper specific recommendations based on what you need in your life. This is why I think it's important to learn AI, because if, like, imagine what your life would be like if you could break free of the prison of these recommendation algorithms, because the internet is vast. Let's have a conversation about this, and this is a tangent, but tell me how many videos are on YouTube. And only public videos is what I'm interested in. Okay, and there's an issue where it's not being fast today, but that's okay. Sometimes it's faster than others. Yeah, so there's 500 hours every minute. So how long would it take one person to watch 500 hours of video? Well, it would take them 500 hours, but let's get a better. Right. So if you watch for 8 hours a day for your job, like a full work day, you would watch. You would have to watch for 3 months just to watch the new content uploaded in the last minute. So if we do a timer for 1 minute, now there are 500 um, hours of video being uploaded to YouTube during this time. So for me to already we're at a point where we're about 2/3 of the way through the minute. So we're at a point where it would take me a full month just to see everything that's been uploaded now. Now we're at the point where it would take a month in a half, and we're almost at the point where it's going to take 3 full months just to see everything that's been uploaded to YouTube during this time here. Now tell me, does this mean all content or just public content? Does it change if I ask about just public content? Now, five, four, three, two, one. Now it would take me 3 months in this period of time to watch everything on YouTube. Okay, well, actually, it includes both public and private. Okay, so it's not exactly as compelling as I thought, but I think the point still stands. Imagine a world where this sentence is radically different, rather than the sentence being based on your purchases, you might want to buy this, which is what these algorithms do from these billion-dollar companies with some of the smartest people working for them. Imagine billion-dollar companies with the smartest people in the world and possibly even throughout history working at them, dedicated to, based on your blank, and fill in the blank with desires, passions, hobbies, interests, health issues, um, based on your best possible life for your age, your gender, your circumstances you were raised in. You might want to blank, or that whole thing, instead of you might want to, we will pay you to. Imagine the world where AI is radically aligned to the individual. Right now we live in a world where AI is out of alignment, and what AI wants you to do is buy more things, and it wants you to buy more things based on the things you bought before. So, just imagine tomorrow, if somebody fixed this tomorrow, next week, next month, imagine what that world would look like if these recommendation uh, algorithms worked better, and caused measurable, provable improvements in people's lives. Like, imagine that world. All right, so moving on. I'm referring to the set of algorithms intended to detect frequent patterns and surface hidden relationships that may be relevant for the user or other stakeholders. The most frequent applicability example of these is to analyze transactions and their components, such as the ones in a supermarket. The main goals are: number one, identify which are the most frequent combinations of components, say articles that are purchased together. Two, and also identify relationships. When these components appear in the transaction, there is a X% probability that this other component will appear as well. These techniques allow businesses to define commercial offerings, taking advantage of the probabilities and relationships identified. However, you may wonder, how is this related or applicable to my network? Generically, these algorithms allow us to identify frequent and potentially hidden patterns in transactions, which each of which is a set of elements. And again, imagine a radically different world where AI is aligned in a radically different way. Instead of transactions, it were based on delta differences, changes in data. So I'm obese. I'm very overweight right now. Imagine if an AI algorithm identified frequent and potentially hidden patterns in my weight fluctuations, because I have weight fluctuations every day, and it could recommend that I keep doing the things that I do that result in lower weight. So, like, if I exercise more that day, if I don't eat, so much at night, if I don't order takeout, the AI can say, hey, if you want to lose weight, and it can send me an alert in real time. So, like imagine a world where AI is radically aligned to work with humanity. We could so easily become a interplanetary species because like everyone would be in perfect health, everyone would be able to accomplish goals together. It's just so important to get AI alignment right, and we can think very easily, just how wrong it is, and it's unfortunately probably going to continue in that direction. The, Identifying frequent and potentially hidden patterns in transactions, you can do that with that what you will, and I think transactions themselves are often not the thing you necessarily wanted to do. It's the advertising gets you, oh, this is a tasty potato chip that's flavored with Fiesta nacho seasoning. It's like, well, I'm going to have that not because I, because in my weakest moment, it enticed me, it seduced me, it's manipulative. It is almost, it's a manipulation, and as I said, these are billion-dollar companies with some of the smartest people in the world, if not throughout history, and they're not radically aligned with what I want. I have to take great care and means to curate what I see online, and even with how good I am at that, I believe I'm pretty darn good at that. I still fall for it all the time. So each of which is a set of elements. These algorithms are being applied already in multiple environments, including IT, to analyze failures. What if we consider an alert in your network as one such transaction, and the elements or components of it are device vendor involved in the alert, device model involved in the alert, device OS version involved in the alert, device zone, device role, if there is a configuration change involved or not, temperature, and a diagnostic tool set as well. What if it triggers a diagnostic series of commands, and then you get that output back? Because what's the first thing you're going to do if there's a problem in the network? You're going to log into the device and look around, or you'll log into the tools and look around, so it can consolidate that all into an email and show you everything you need to know just instantly at a glance, rather than having to pour through everything. That step is already complete. There could be many factors that are, or maybe are not, involved in the existence of that alert. For example, the transaction. We do not know exactly what those factors are. However, we can identify patterns and commonalities using the same association rules algorithms others use to plan their marketing campaigns in a supermarket. One challenge with these algorithms is that they are very computationally intensive. Many combinations need to be counted. However, as mentioned already, brute force is your friend, and the outcomes and benefits likely outweigh the costs. Before diving into the algorithms, reviewing a few concepts we should be familiar with is convenient. Let's say that we have a particular combination of factors. A equals, and then we've got curly braces, so this is a combination of factors. The first factor is F1, which I assume stands for factor 1. And then we've got F2, F3 in a continuous sequence, increasing by 1 each time, up to whichever number you specify. It appears with B equals network alert. To a higher or smaller degree, these factors are associated with network alerts. Now we need to understand how high or strong such an association is. Therefore, the combination we are looking for is A, and then oh, and now I don't know if this is an arrow or if this is a greater than sign and a minus sign, but hopefully that will be explained. A is usually referred to as the antecedent, and B is the consequent. So yeah, this is an arrow. It's A leading to B. It's kind of a cause and effect, I think, as it understands. Essentially, if A happens, then it will lead to, then B happens with a certain probability. Yeah, so that is a good explanation of that. The combination we are looking for is we have some event happen, and then it leads to, so the event that happens is the antecedent, and then the B is the consequent. So I really like the word contingency because I was a big player of Baldur's Gate 2. It's probably my favorite game still to this day, and one of the really fun things you could do as a mage is basically program. Like, it had kind of a programming language in, and you could build these what are called contingencies. So let's say that you see an enemy, you could program your mage so where if you see an enemy, then you trigger a protection spell, and you do all this magic to basically put on a magical suit of armor with spells. So like, I like that word contingent because it's from there, and I think it's a great word to use here. So B is contingent upon A, and B, yeah, so, but it's a little bit different because it's specific to this context, which is machine learning for network and cloud engineers, and not Baldur's Gate 2. So I need a quick pause, and when we come back, we'll do support. All right, welcome back. So, support. Support determines how frequently the set of elements of interest is out of the total on the dataset. We could collect all the factors referred to in A at a specific frequency from all the network devices. Then add B if there is an alert associated or not. In that case, we could compute the support for A as support subscript A equals frequency subscript A divided by total entries in sample. This is essentially the probability of A. Likewise, the support for A as a antecedent, which will result in B happening as a consequent with a certain probability, would be support subscript A, comma B equals frequency subscript A, comma B divided by total entries in sample. It is an estimation of the probability that A and B happen at the same time. These support values will probably be, in general, small values in the type of example referred. Let's review more concepts. Confidence. Confidence provides a more targeted context to quantify how frequently association A-B happens compared to how frequently A happens. Interesting. So it's going to happen less frequently, of course. essentially how strong such an association is. Yeah, so this is like, causation. I think a lot of people have heard correlation is not causation. Well, correlation can be good evidence of causation, and in fact, if the correlation is meets certain metrics, if the math on the correlation works out in a certain way, that can be really good evidence of causation, because the when that sort of statement is made, it's referring to empirical evidence. So yes, something with a strong correlation. I drink water every day that I, you know, do. So it's like you can make false correlations to things, but there's a whole system of mathematics that can do that in a proper way and help procure empirical evidence. If that association is perfect, then every time A happens, B will be true. The confidence will be 1. Now we can get a sense of how strong the association is, and therefore that A drives B. Why do I use around? Oh, so why quote this? Why quote this word drives? So why do I use quotes around drives? And I wish there were an easy way to get rid of that. What if I push escape? Escape works. Okay. Because drives implicitly refer to causality, strictly speaking. We are obtaining association here. And this chapter is about association? No. Oh, yes. So we're talking about association rules. Association is not necessarily causality, but we can have in our mind a causal model based on the domain expertise we have. Based on that model, we can infer that those factors truly drive a strong association between such factors and the existence of alerts. It could still be that there are other common factors, aka co-founders, that we are not taking into account. But I will leave that explanation for the causal inference section of the book. For now, let's just assume the term drives as a sort of causality relationship. But again, as they're saying, drives is right. So we're talking about. So we're going to assume that the term drives means some sort of causal relationship, but in this chapter we're talking about association, which is not necessarily causality. So we're talking about the mathematics of determining association. So when we use that word drives, we're using it maybe not in the best way, because we're referring to causality, but we're not talking about causality necessarily. We're talking about association. So it could be that there is no association. It could be that there is no causality. So when we use the term drives, we make a big assumption, and the goal of this is to mathematically validate. The goal of this is to determine whether or not something is associated. So if we use drives, we kind of put the cart before the horse, and we implicitly say it is causal, but our goal is to do association mathematics to determine that and not just imply it implicitly. Okay, so one of the ways we can do that is this equation here. So it's confidence subscript A comma B equals support subscript A comma B divided by support subscript A. So let's take a moment here. We've got a few equations here. So let's just plug each of the equations we've come on to so far into ChatGPT. I like how ChatGPT has been just kind of volunteering information about this. So let's just plug these equations into ChatGPT as they are through screenshots and see what ChatGPT has to say about them. All right, and then when I'm done with that conversation, I will come back and read about Lyft.
It looks like you've uploaded 3 images, likely containing mathematical expressions. Please let me know what you'd like to do with these, or if you have any questions about them.
Okay, yeah, so the first thing let's do this first. So read out each of the equations in English. So like, for example, I think the first equation, the way you would read it would be support subscript A equals frequency subscript A divided by total entries in sample. But what I want you to do is read it out in English in the most appropriate, perfect mathematical way so that the meaning of the mathematics is preserved. And I want you to do that for all 3 of the equations. And this looks like it's a little bit hard for it to do, but let's look at the book while it's doing this.
Certainly. Here are the mathematical expressions read out in English in a mathematically appropriate way. The first equation, support of A equals the frequency of A divided by the total number of entries in the sample. The second equation, support of A intersect B equals the frequency of A and B together divided by the total number of entries in the sample. The third equation, confidence of a given B equals the support of A intersect B divided by the support of A. These expressions are commonly used in the context of association rule learning and data mining. The support refers to the proportion of the data set that contains the item set, while confidence is a measure of how often items in B appear in transactions that contain A.
Good. Now I noticed that you use terms like support of A. Is that okay? So that's interesting that you would say that, because first of all, the equation. Okay, yeah. So you say support of A. So like that word of. Is that like how you would read it? Now, how I read it is I said support subscript A. What is the difference between referring to it as support of A and support subscript A, and which is more mathematically appropriate that preserves the mathematical meaning the best?
In mathematical notation, a subscript is often used to specify a particular instance or element of a variable. The use of subscript in the description is more about the presentation of the variable rather than its mathematical meaning.
Oh, okay.
Saying support subscript A emphasizes the specific way the symbol is written. It points out that the letter A is placed as a subscript to the word support. This description is more about the visual representation rather than mathematical relationship. Saying support of A, on the other hand, conveys the mathematical relationship or the concept that the support is specifically associated with the item or event A. It implies a functional relationship, which is often how mathematicians will orally communicate the meaning of the expression during lectures or discussions, as it flows more naturally in conversation.
Good.
For preserving the mathematical meaning while also being understandable in spoken language, support of A is often preferred. It correctly indicates that we are talking about the support measure corresponding to the item set denoted by A. This is especially true in the context of association rules where support is a function of the item set in question. The subscript is used to indicate which particular item set the function is being applied to. In formal mathematical writing or during presentations, one might use support subscript A if it is necessary to be very explicit about the notation, especially if the visual distinction is important for the discussion.
Good.
However, in a spoken and less formal written context, support of A is more common and understood to mean the same thing.
Oh, okay. Okay, so yeah, I guess I want to be more formal, like, using official mathematical writing. Like, my goal is for the meaning to be preserved, the meaning, MEANING. I want that to be, I want the meaning. I want what the symbols mean. I want the mathematics to be preserved, and I don't want the meaning is really the best word. I'm sorry, there are some typos because I'm using voice to text, but I think you know what I mean. So yeah, I want to focus on formal mathematical writing, and I want other mathematicians and professionals to take seriously what I'm saying. Like, I want to actually, like, let's say that I were learning the language, Spanish. Like, I wanted to be able to speak that language in a professional way so I could work a job in Spain or Mexico. So it's like the same thing. I'm learning the mathematical language, so I want to be able to use it in a way where I can work a job in mathematics and function at a high professional level.
Understood. For a formal and precise mathematical setting, especially when the context requires unambiguous communication of the symbols and their exact notation, you would indeed lean towards the explicit description of the symbols as they are written.
All right, so I think that's... But does it make sense to refer to just the symbols? Like...
So here's how you could articulate the equations with an emphasis on formal mathematical writing. Support subscript A is equal to frequency subscript A over total entries and sample. Support subscript A comma B is equal to frequency subscript A comma B over total entries and sample. Confidence subscript A.
But does it make sense to focus so much on the symbols? I mean, like, as you said, if I say support of A, that is the meaning, and that is the meaning preserved. It's like we're supporting A. But if I say support subscript A, then yeah, like, how to write it in mathematical symbols, but what does subscript mean? I feel like the meaning is far less preserved if we focus purely on the symbols. And you can write the symbols in a clearer way, but if the goal is to communicate meaning, which I think there are some typos, but if the goal is to communicate meaning, then I think using that word of makes so much more sense. And I can't really imagine that people would, in a professional context, decide to focus on symbols rather than meaning. It's the meaning that counts, right? Yeah, okay. So you could do either or.
Absolutely. In professional mathematical communication, the meaning and the relationships between the mathematical entities are indeed what's most important. The symbols are tools we use to express these relationships in a concise and universally understood manner within the mathematical community.
Right.
When speaking or writing about mathematics, the goal is to convey the concepts clearly and precisely.
But the word of is pretty
In the context of the equations you presented, which are typically used in data mining and statistics, emphasizing the meaning will indeed make the discussion more fluid and comprehensible, especially when discussing the concepts verbally or in prose rather than in written symbols. So for the equations you are working with, describing them as support of A is calculated as the frequency of A divided by the total number of entries in the sample. Support of A and B is calculated as the joint frequency of A and B divided by the total number of entries in the sample. Confidence for a given B is calculated as the support of A and B divided by the support of A. This phrasing clearly expresses the mathematical relationships and is the preferred way to communicate these ideas in spoken language and in written explanations where the audience is expected to understand the underlying concepts without needing the explicit notation presented every time.
Right.
In mathematical discussions, the focus is indeed on the concepts and their interrelations, and this is what gives meaning to the symbols rather than the symbols themselves.
Yeah, you can use either or. It just depends on the context if you're telling somebody to write the equation, you should probably use subscript, and so all right, so let's move on to lift. I need to take a quick break. I'll be right back. Alright, I'm back. So next section is lift. Lift is our third concept to learn. It indicates how much more likely B will be the consequent in the presence of A, the antecedent. And I believe the word is antecedent. Let's get a pronunciation of it. So I'll click full definition here for this pop-up. And it takes me to a dictionary, which is not where I want to go. We also notice that it doesn't take me to the definition of the word. It takes me to the front page of the new Oxford American Dictionary, which we can see is a very large book. So it actually not only didn't give me the definition, it basically disrupted my work. So let's click the back button. Okay, so that wasn't so bad. When I clicked the back button, I was able to get back to where I was. So now if I double click it, I get the same menu. So instead of double clicking, what I'm going to do is highlight it. All right, and then click copy. And then plug it into Google and get rid of the author information. And click the pronunciation button.
Antecedent.
Antecedent. Yes, I have heard that anti.
Antecedent.
Ante.
Antecedent.
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 So
Antecedent.
antecedent. Yeah, so it's like an ant. Yeah, so I hate my Russian doll. She is so full of herself. Antecedent. And what is an antecedent? It's a thing or event that existed before and logically precedes another. In our example, and something happened here. Okay, so it looks like it put some more text on this page rather than the other one. That's fine. So click the bookmark again. Now the bookmark took me away from what I was doing. So let's see if I can leaf through the pages back to where I was. There we go. That wasn't too bad. So, okay. So this is where I was. In our example, how much more likely is it that there will be alerts in your network due to the presence of a specific set of factors characterized by A? So we have an equation for that. The equation is lift of a. Okay, so I think this is a great exercise. I think when it comes to mathematics, you should be able to naturally read equations the way you would naturally read an English sentence. So I'm going to use ChatGPT to help me learn that skill. So I believe a really good way for learning mathematics is to be able to naturally read an equation the way you would naturally read an English sentence. Assign a letter grade to this belief about mathematics. If it's anything but an A+, tell me how my beliefs and intuitions could improve. If this is a good way to think about mathematics, help me develop this skill. If it is not, help me develop better skills. Good.
Your belief in learning mathematics by being able to read equations as naturally as sentences is indeed a sound approach, especially when dealing with concepts that lend themselves to verbal explanation. I would assign this approach an A, because while it is a valuable skill, there are nuances in mathematics that sometimes go beyond natural language, where intuition needs to be supported by a rigorous understanding of definitions, theorems, and proofs. For the equation you provided, which represents the concept of lift in data mining and statistics, we can develop this skill by practicing translating the equation into a natural language explanation. Here's how the equation could be read out loud. Lift of implies B equals the support of A implies B divided by the product of the support of A and the support of B. Now, to unpack the meaning within a mathematical context, lift is a measure used in statistics to determine how much more often items A and B occur together than they would if they were statistically independent of each other. Support of implies B, often written as support of right pointing arrow B, is the support of the rule, indicating how frequently the combination of A and B occurs in the dataset. Support of A and support of B are the proportions of the dataset containing A and B, respectively. By reading equations like sentences, we connect the abstract symbols to their conceptual meanings, making the math more accessible. However, the skill also lies in understanding the deeper implications of these equations, which sometimes requires going beyond the surface level reading. For instance, understanding lift requires not just being able to read the equation out loud, but also knowing what support means in different contexts, how independence is defined in probability, and how these concepts interact in the context of the problem you're examining. To further develop this skill, practice explaining mathematical concepts in plain language. Work through examples where you calculate the lift, support, and confidence, observing how changes in the data affect these measures. Discuss these concepts with peers or mentors, explaining your reasoning and understanding their explanations. If you encounter an equation that doesn't naturally translate into a sentence, that's a sign that you might need to dig deeper into the underlying concepts. This approach will help you develop a robust mathematical intuition that will serve you well in professional contexts.
Okay, so that's a good answer. Generally, yes, that's a letter grade you would get is an A for wanting to do that to develop your mathematical tuition. However, it's not quite an A plus because once you get into the really advanced mathematical stuff, in order to unpack a term, you'll have to it condenses a lot of information, and you can't just use a simple word or phrase to define a really advanced mathematical concept. So an A plus way of understanding mathematics would be to develop a really deep intuition and understanding of the symbols rather than reading the skill of reading a sentence out loud as with as much kind of ability and ease as a English sentence is not as important as the skill of deeply and intuitively knowing what the symbols mean, even if you can't quite put it to English words, because it's not, mathematics isn't the same as the English language. But I like the word implies for this symbol, so let's read it again. So lift of A implies B is equal to support of A implies B divided by support of A times support of B. If we interpret this equation as probabilities, this is equivalent to, and let's do this again. So good. Now read the equation in this screenshot.
The equation in the screenshot can be read as follows. Lift of A implies B is equal to the probability of A intersect B divided by the product of the probability of A and the probability of B, which is also equal to the conditional probability of B given and divided by the probability of B. In mathematical terms, this is expressing how much more likely B is to occur given that A has occurred than just the likelihood of B occurring in general. The lift provides insight into the strength of an association rule in statistics and data mining.
All right, and let's have that read again, but we'll have it read it a lot more slowly now, which unfortunately I can't. For some reason, having it read it again has been deactivated. So you know what? Let's forget it, and I'll read it myself. So lift of A implies B is equal to the probability of A intersect B divided by the product of the probability of A. So that's this P colon symbol here, or not colon, parentheses symbol here, and the probability of B, which is also equal to the conditional probability of B given A divided by the probability of B. So we can see that we've got a new mathematical symbol here, a mathematical operator. So tell me more about the mathematical symbol. Looks like it includes syntax. Is there more syntax associated with it? For example, I would assume that it includes times plus are my mathematical intuitions correct? How can I improve them?
The P notation typically denotes a probability measure. In mathematical probability, P stands for probability, and the symbols within the parentheses refer to specific events or conditions related to that probability. Here's what the different symbols commonly represent. P, A, the probability of event A occurring. P, A intersection B, or P, A and B, the probability of both events A and B occurring together. P, A union B, or P, A or B, the probability of either event A or event B occurring, or both. P, A, B, the probability of event occurring given that event B has occurred. This is known as conditional probability. P, A, or P, not A, the probability that event A does not occur. The syntax you're referring to, like P, isn't standard notation in probability theory. You might be mistaking the conditional probability notation, P, A, B, for P. The bar stands for, given that, in conditional probability.
Okay, so there's actually a typo in the book, which is interesting. So this is meant to be the pipe key, not the /. This is not a valid symbol in probability. So and it looks like this mistake is made again here. This needs to be a pipe symbol, not a /. So I honestly, you know what? I think I'm going to. I think I'm honestly going to email the author on that because this is an important one. I think this is a very hard chapter to understand. So when things like that happen, the wrong mathematical symbol is used. I think it makes it especially difficult to understand. And in an era without ChatGPT, that mistake of thinking that it was A divided by B rather than what it actually stands for, which is conditional probability, that could really mislead someone learning about this new. And I think it's a really simple thing to correct. So let's go back to the beginning of the book and read about the part where the author talks about contributions, because the author wanted to have people help out with editing. I remember he explicitly said that somewhere. And I'm trying to remember where it was. I'm pretty sure it definitely would have been at the beginning of the book, because that's where I read. But I want to make sure I do this in the official channels that he wants it to be done so I think it was in this section, the "Who is this for" section. Okay, so he would love to hear. This is it. He would love to hear the feedback. So unfortunately, I don't see the official channels. So I'm going to do it in the only way I really know how. I'm going to contact him on LinkedIn. So I'm going to send him a message. I'm going to say, the name of the book. So the name of the book is Machine Learning for Network and Cloud Engineers. And then I'm going to say correction. I'm going to say, hi, Javier. I'm loving your book on I'm loving your book. I'm reading it for a series on my YouTube channel. Okay, and then I'll link to the series. I noticed a mistake in the mathematical notation on page 50. Of the ebook. The operator for conditional probability is written as P using a forward slash. I am no expert, but according to ChatGPT, the correct operator is which uses the pipe key rather than the forward slash. It is a small difference, but in understanding, it can lead to misconceptions in my case. I interpreted attached is a screenshot of the first instance of where this correction is needed. Here is the Wikipedia article on conditional probabilities. where it is clear that the pipe key is being used and that there is no use of the forward slash character to denote division. All right, so now we've got the screenshot here. So I'll highlight this in a red text because that's the kind of person I am. And I will save this in my downloads folder. That's kind of where I like to save things by default. And I will say book errata and save and attach it. Okay, and now I will reread what I wrote. So I'm loving your book. I'm reading it for a series on my YouTube channel. I noticed a mistake in the mathematical notation on page 50 of the ebook. The operator for conditional probability is written as B using a forward slash. I am no expert. According to ChatGPT, the correct operator is which uses the pipe key rather than the forward slash. It is a small difference, but it can lead to misconceptions. Attached is a screenshot of the first instance where this correction is needed. Here is the Wikipedia article on conditional probability, where it is clear that the pipe key is being used and that there is no use is being used. And then on another paragraph, I will say there's no use of the and I can do it all in one. That's fine. Doesn't have to be perfect. There is no use of the forward slash character to denote division. Okay, so there we go. See how easy that was? You know, I think a lot of people are hesitant to do things like that because of the spotlight effect. So let's open the list of the cognitive bias index. So okay, so here it is. This is the one I'd like to look at. So, and then let's see if we can do a okay, so what would it be? What would it be under? Spotlight effect. I feel like it would be part of the what should we remember? Error of the brain. It might not even be on here, but I think one thing that prevents people from doing this sort of outreach, which I think is critical for having a robust professional network, is something called the spotlight effect, where people are worried that they're going to be judged harshly, that somebody's going to remember what you said to them and kind of hold it as a grudge for the rest of their life, or like you're going to ruin your reputation or things like that. I think people generally don't think of things besides what's in their own mind. And for you to really transgress and ruin your reputation and come off as really bad, you would have to make really, really big mistakes. You'd have to be like the most, and even then, they might overcome it. But if you're just not on that level yet. Like if you form a relationship with them, and then you screw them over, and they, then they're going to remember it. But if you're just reaching out to someone like this, this is just a basic skill when it comes to building a professional network and contributing to the space you exist within as a professional. You have to be willing to reach out to people, especially when you do it in a good faith way, as I did, to point out an error in their work. People will love that. That's the author explicitly said that in the book to do that. He told me to do that in this book, so that's what I did. If we interpret this equation as probabilities, this is equal to that. We went through that in ChatGPT, where the probability of A equals the probability of A happening. The probability of A and B is the probability of A and B happening, both of them happening. And then the conditional probability of A and B, and remember this is a mistake here. This should be a pipe character, not a /. This is the symbol for the conditional probability of B given A, and why this is kind of a problematic mistake is because we're not denoting division here. We're using a special syntax to denote conditional probability. So it has nothing to do with addition, nothing to do with multiplication, nothing to do with subtraction, nothing to do with addition. It is its own syntax for denoting conditional probability, and there's an error in the syntax here. This should be a pipe key, not a /. Therefore, the lift is equivalent to the ratio of the conditional probability of B given A divided by the probability of B, which means if B is more likely in the presence of A than A by itself. That means A is driving a lift in B. In our example use case, the factors contained in A produce an increment in the probability of an alert. When lift is greater than 1, it means A positively impacts B. When lift is less than 1, it means A has a negative impact on B, which is also relevant. When lift equals 1, it means there is no relationship. Let's review two of the most common algorithms, a priori and FP growth. A priori is an iterative algorithm that follows a process referred to as candidate item set generation. K item sets with K items, are used to find K plus 1 item sets. It is a basic algorithm, not necessarily the fastest or more efficient. While a priori constructs sets, the FP growth algorithm builds a tree structure, enabling a much faster analysis. We will not discuss the details of the algorithm itself. We will see a practical example with code later in the book in the section on use cases. Key takeaway: finding frequent patterns is extremely useful with lots of different applicabilities in multiple fields. It's all in the data. So the next part is recommendation algorithms. I can do a bit on that, probably at the hour mark, which is kind of the max I can do typically. Yeah, we're at the hour mark. Sometimes if I'm really feeling it, I can do longer than that. This next section looks like it's got a lot of new concepts. We're going to talk about stochastic gradient. It looks like stochastic gradient descent, which is kind of a big one. So I do want to do this in another video, actually, because I want to be able to devote more time to these concepts. So that's it for this video. Thanks for watching, and see you in the next one.